Hey, Calc class, this is your third video. You're going to have a test next week, Tuesday the 21st. You want to make sure you get ready for that. In order to do so, obviously, you're going to watch this review video. You're going to have the test between 10 and noon. That's when it's accessible. So if you can't do 10 and noon on the 21st, please let me know. But, that's I'll have to make up a different test for you then during that time. But please, 10 to noon, make that happen. If you have work, ask if you can have your work hours adjusted or something. If you're not comfortable doing that, then reach out. But, I don't ask you guys to do something specifically at a certain time, really throughout the entire weeks. It's nice if we could get your two tests to be at a certain time. So this would be one, and then you have one at the end of the semester. So there's just going to be 4 problems, pretty straightforward. 2 problems per page. I'd like you to copy the problem down onto a sheet of paper and then go ahead, produce a graph, produce the integral, show your bounds, do the antiderivative, and give me your answer. So I want to see all that. Rachel, let me know of Cam Scanner. It's an app that you can download to your phone. It takes excellent pictures of your homework to be able to be submitted. You can go ahead and send that to me, and that would be just fine. So again, if you could take these and then submit them into the Google Doc of the test, that'd be very, very helpful. Again, I try to space out your work and take excellent pictures of your work so I can read it and understand it. Again, send me your work, not just your answers. I try to be very clear to this to people, and I've commented on a lot of people's homework when I haven't been able to see sufficient work. I have to see your work. This is very important. Okay, so do that, or your grade will reflect. So when mid quarters come out, so that's all I can say. This is an open note. It's open homework, open videos that I've created. This is not open phone, open internet, or open partner. Some people may just dismiss that, meaning, well, I'm going to do whatever I want. That says a lot about your character that you're willing to cheat. And so I don't know what else to say other than I wouldn't want to work with you if you're interested in cheating. I wouldn't want to co-work with you. I wouldn't want you babysitting my children. So don't cheat. I'm trying to make this as straightforward as possible. Do what you're supposed to do. Own your own work. Do it yourself. Hand it in as such. Okay. So just to be clear, again, if you have to take a little bit extra time to make sure that your handwriting is neat, then do that. Again, it's a 2-hour window, and not only is it a 2-hour window, it's only 4 problems. So take your time, show your work. So during the course of the rest of this video, I'm going to set up for you 4 problems to kind of help you as you review for this test. I will produce the graphs for you on the test, so you won't have to try to figure out what I'm talking about. But I'm not going to go through the business of actually doing the entire evaluation process of the antiderivative. That's something that you can do on your own, as I'm sure we're all comfortable with that. So the first one, you're going to have to be able to do area between. And in this situation, we're going to do y equals x, and y is equal to 12 minus x squared. Okay? And so if you graph that, I will have the graph produced for you as you take your test. Y equals x looks something like this, and 12 minus x squared looks like that. Okay, we want to find the area between those two things. Well, how do we do that? Well, we take the top minus the bottom. So you have 12 minus x squared minus x. Okay? And so if you look at the rectangle, again, the width of the rectangle is dx. The height is the top minus the bottom, top minus the bottom. That's one of those. You want to do an infinite number of those. We have to be able to know our bounds of integration. So we go from here to here. In order to determine that, we find the intersection, the x values. So we would say, where is x equal to 12 minus x squared? If you add the x squared over, I get x squared plus x minus 12 is equal to 0. And so you have x plus 4 times x minus 3. So negative 4 is one x value, positive 3 is another x value. So negative 4 to positive 3. Again, this is all work that I want to see on your test. I want to make sure that's very clear. We take the antiderivative, and in that situation, you get 12x minus x cubed over 3 minus x squared over 2. We evaluate it at 3 and negative 4. You go ahead and plug those in. I'm trusting you can see it from there, but that's our first example, area between two curves. Our second example that we want to look at is volume by discs. For example, in this situation, we are going to look at y is equal to 3 minus x and y equals 0 around the y-axis. Okay? So as we generate this shape, and I'll produce the graphs for you, 3 minus x is going to look like this. And y equals 0 is going to be the x-axis, and we're revolving that around the y-axis. So as you spin it around, that's what you get. As we have a horizontal revolution in that case, we are going to draw a horizontal rectangle. As we spin that around, you can see that you are going to get a disk. How do we find the volume of a disk? We do pi r squared times the width. The width here is vertical width, so it's dy. Now I need to produce r in terms of y. Right now, this radius, this distance from here to here is my function, but my function, because it's dy, it should have a y in it, not an x. So therefore, if I add the x and subtract the y, I get x is equal to 3 minus y. So that's what goes in for r. So we have pi times 3 minus y squared dy, and we integrate from 0, and we're going to go all the way up until 3. You need to multiply that out. Pi times the integral 0 to 3 of y squared minus 6y plus 9 dy. And then we go ahead and we take that antiderivative. Y cubed over 3 minus 6y squared over 2, which would be 3y squared plus 9y evaluated at 3 and at 0. So that's how you would set up our second example, which would be volume by discs. For our third example, we would look at volume by washers. And we are going to look at y is equal to x squared, and y is equal to 4 around the x-axis. Again, I'll produce the graph for you so you can see exactly what you were looking at. I go ahead and draw that graph, which is y equals x squared. I draw my graph of 4, which is that right there. So I'm going to take that and I'm going to flip that around. And as I do, you can see that if you were to take this rectangle and rotate that around, you would, in fact, get that hole right there. And then here, we have the outside that has the actual area. We have a washer. The volume of a washer is pi times big R squared minus little r squared. So we need your big radius, we need your small radius. By looking at this, you can see from there to there is our big radius, which is in fact 4. Our small radius is from there to there, which you can see is our function, or x squared. The thickness is dx. So therefore we have pi times big R squared, which is 16, minus little r squared, which would be x to the fourth, dx. And we integrate from what to what? Well, we would need the intersection of these two things. So where is x squared equal to 4? Well, that would be at -2 and at +2. Okay. Now, it is symmetrical on both sides. So therefore, you could do a trick here. You could do 2 pi times the integral 0 to 2 of 16 minus x to the fourth dx. That's what I would do. Now go ahead and find the antiderivative. We have the antiderivative 16 is 16x minus x to the fifth over 5, evaluated 2 and 0. Go ahead and plug those values in and you'll come up with your volume. For your last one, we are going to look at, whoops, sorry, that was number 3. I keep on forgetting to change that up there, sorry. Our last one we look at is what you worked on this week, volume by shells, cylindrical shells. This is number 4. And we look at y is equal to x squared minus 4x plus 5, and and x is equal to 2, and x is equal to 0 around x-axis. So the graph is going to look like this. I'm sorry, around the y-axis. This graph looks like this. It's actually shifted over. Shoot, I'm going to change that. Oh, that's fine. If you look at this graph, it's a parabola. And the way I've constructed this, a little bit different than I intended, but that'll be okay. The graph has a vertex over 2 and up 1. And so this is the shape. And it says we are also going to bound it by x is equal to 2 and x is equal to 0. So we're going to bound it here. We're going to bound it here. We'll also bound it here again. I'll produce the actual shaded region for you, and then you can go ahead and rotate it. So cylindrical shells, we take this guy, a vertical rectangle, and we're going to rotate it around. And you can see as you do, you get this shell. How do we find the volume of a shell? We unravel it. And when we do, we get a rectangle. The height of the rectangle happens to be the function, x squared minus 4x plus 5. The radius is just x. So this distance is 2 pi times your radius, or x. So, and our bounds are from 0 to, in this case, it says 2. So the volume of one of these is 2 pi x, the width is dx, times x squared minus 4x plus 5 dx. We would like to have an infinite number of those, so 2 pi times the integral of x times x squared is x cubed minus 4x squared plus 5x. Evaluate from 0 to 2 dx. Go ahead and take that antiderivative. X to the fourth over 4 minus antiderivative is 4x cubed over 3. And 5x is 5x squared over 2. Evaluate 2 and it's 0. And you just plug them in and you evaluate. That's your review. Hopefully that's something you feel like you can set up. If you need to go back and practice those, go ahead. But I should be good to go. Go ahead and reach out to me if you'd like to go over these questions before your test next week, Tuesday. See you later.